Okay, in this chapter we discuss about structure. Okay, this is the basic structure declared here with the two elements. One is integer my role and character my cat. So, and at the line number 14 you can see here the structure is defined. The S is defined a structure. The S is defined to my struct. Okay, now we can access my role and my character using dot here. S dot my role is equal to the number 25 and S dot my char is equal to the character P that is assigned. So this how we can write values of the members. Yes, and if you want to read, you can read S dot my role is equal to, and you can print using S dot my role and S dot my character. In the output you can see the my role is printed with 25 and my character is P. So simple dot operator we will use, and S dot my role and S dot my character can be used and accessed for writing and for the reading. Okay, let's move on to the next example. So here, so along with my role and my character, we have a my pattern for 30 words. So here you can see while defining a structure S1, the S1 is initialized with 25 P and C language to the my pattern. Okay, and you can read all the values using the S1 dot my role and with the dot operator all the elements. And if you want to copy all the elements from the S1 to S2, you can do that using S2 is equal to S1. This will copy all the elements from S1 to S2, and you can read the values from S2. So S2 will also print the same value as S1, 25P and C language. So we can copy all the elements from structure to the other structure like this assignment, simple assignment with the defined structures S2 and S1. Okay, here we discuss about why we need string copy. If you want to copy the string, that means character array, if you want to copy from one structure to other structure, you may need string copy. Okay, let's understand with the example here. So we have defined the structure with integer character and character array. So now S1 is defined and S1 assigned with these structure elements. Okay, and also I try to read the values using the printf. Okay, here one of the way is S2 is equal to S1, will copy all the elements and printed S2 and it's printing. But if you want to modify individual values, say for example S1 dot my role, you can modify with a simple assignment, and S1 dot my char you can modify the string, the character using a simple assignment. But if you want to modify the character array, that is string, you cannot use assignment operator. Instead of that, the assignment operator will not copy all the elements. So that is not the right way, that is the invalid way. So for that you need to use string copy S1 dot my pattern comma C programming. This will copy the C programming into S1 pattern, and now I try to print the S1. So S1 will print modified values of 35D and C programming. Okay, so to modify individual character array, you need to use string copy instead of simple assignment. Okay, let's move on to the next example where the structure can have another structure as a member. That means nested structure. Okay, the example is we have a owner as one structure that contains first name and second name, and the paint as one more structure. Here the paint will have owner as one more element inside the paint, That means the owner is nested with paint. This is called nested structure. Now owner is defined here. In the definition you can see the owner is defined with person with some elements here assigned, and the paint is defined with paint1, where paint1 having one more structure as a element of type person. So now person is mentioned here. So this is how we can access the paint1.make. The paint1.make will be accessed like this. But if you want to access the first name, so paint1.owner. So paint this owner, and this owner indirectly access first name and last name as a. So you can see the paint1.owner dot first name, two dots and three direction reference are there. Paint1 owner first name, like this paint1 that owner and the last name is accessed. This is like nested structure we can use. So whenever there is a nested structure, and it is useful when you want to group related data together in layers. So this is the advantage of nested structure. You can have one more structure in the another layer of paint. Okay, let's move on to the next example where we can have so pointer to the structure. So this, so you can use pointer to struct, make your code more efficient when passing struct to function or changing their values. To use pointer to a structure, just add the star symbol. To access its member, you must use hyphen greater than operator instead of dot syntax. Okay, let's understand this with the example. So define a structure, simple structure. So make, where brand and year will be there. Okay, now define a structure make. So now make define a pointer for the structure make, and pointer is assigned with the make address of make. So this make structure address is assigned to the pointer. Now we have a pointer that pointing to the make. Okay, now if you want to access any of the member using a pointer, you must use hyphen and the greater than symbol instead of dot operator. Okay, and here you know that the string copy is used, copy the Asian string into the brand, and pointer here. So here also accessed using the pointer, because pointer used we need to use hyphen greater than symbol instead of dot operator assigned with the 2020 here. And access member using the greater than hyphen and greater than symbol. You can see how we can access, we can read values this hyphen and greater than operator, and the same is printed in the output. Okay, let's move on to the next example. Here the passing structure pointer to functions. So in this example, so we have two elements defined with make. Now you can see the make is defined with Maruti in 2010, and we are calling the function update here along with address to the structure. So passing here update here, and this guy will receive address and assign to the C, and now C is a pointer to the structure make, and using here member using this operator hyphen and greater than symbol, and updating the year values here. Now the year is overwritten with 2025. If you try to print both the values make and year, so it's printed with Maruti and 2025. 2025 is the updated value here in this update here function. So you can see here, whenever we are trying to use with the make structure, we are using a dot, and when you are using the pointer to the structure, we are using hyphen greater than symbol as a member access operator. Okay. So this is how we can pass the address to the structure and receive address to the structure and use the address in a pointer to access the member. Okay. So with like this, passing the structure pointer, advantage of the passing structure pointer is, instead of passing the structure, we are passing address to the structure. You can avoid copying large amount of data. Instead of copying whole struct, you can just pass a pointer, and this makes your program faster and use less memory. Okay. Yeah, you want to change values inside the function, yes, you can change using the pointer to the address, pointer to the structure. And there is one more feature. If you want to create this structure, so you can see in the previous example the structure is created at the compile time. If you want to create structure dynamically at the runtime, that you can do using the dynamic memory allocation malloc. So maybe in the future videos we see the example of dynamically creating structure using malloc. So with this we can have more control on the memory management, and at the, if it is really required at runtime, we can create a memory, otherwise the structure is not created. So that way we will have more control on the memory management. Okay, and this is about the union. Here I already discussed in one of my previous example in video. There is a very almost it's like a structure, the accessing, writing, reading, the members, everything almost same as structure. The only difference is the allocating memory. Union is similar to structure in that it can store members of different data types. However, there are some differences. In a struct, each member has its own memory, but in a union, all members share the same memory, which means you can only use one of the values at a time. Most of the time, you will use structure instead of unions, as it can store and access multiple values at the same time, which is more common in everyday program. Okay. And yes, union will have less memory footprint, but you can access at one time the latest memory, whatever you return or accessed will be valid. The all other memory will be invalid, become invalid in the union. Okay, and accessing is same as structure, using dot and using the when you want to use union directly, you can use a dot syntax. When you use union pointers, you can use hyphen greater than symbol. Okay, so let's understand this with one union example. So union is declared with 3 element integer character and character array of 16 bytes. Here you can see the I try to print size of the union here. The size of the union is size of u1. This is only 16 bytes. Actually 16 byte, 1 character here and 4 bytes here. It will be more than 16 bytes, but this guy is printing 16 byte because it allocates only to the memory that is bigger among all the elements in the union. So here in this case the 16 bytes is bigger, so 16 bytes allocated. That's why you are seeing 16 bytes as size of union. So this is about the accessing. Union is defined with like union, my union, and my union element here. So my union structure is u1 is defined with union keyword, and u1 dot mynum is now appended with 500. Now mynum is 500, and you are writing. So since this is the last value returned to the union, mynum no longer holds 500 because now is value overwritten with P, because my num and my letter shares the same memory. So whatever the 500 you written, you now overwritten with the P. So you try to access my num here, you are reading with wrong values. So you are expected 500, but this accessed invalid value, and now overwritten with P. So P is valid, my letter is valid, but my num is invalid. Okay. Okay, this is one more um, feature of structure or union is a type depth. So type depth means it's like an alias. So let's understand with one example. Without type depth, what happens, and with type depth, what happens. This is without type depth. Created a car. This is with type depth. Make is created. Here car is created. So struct car1. So here to define a car to the car1, you used car1 structure, but to create a car this make, here in this make the struct is omitted, so directly you are using make. So type depth struct the make, that means now make is having the struct keyword hidden inside the make. So that's why make car2 will do the job, so shorter with type depth. So struct is avoided, you can avoid like this. I am trying to print car1 and car2, so both are printed with expected values. The only advantage of type depth is you can avoid struct here. So struct is avoided, directly use make. Okay, this is about the structure padding. Let me read. Okay, say for example, so we have a definition of structure padding here. So this is the first example. Example 1, you can see the character A is declared, int B, and character C is declared here. So character A, so in a normal situation, the character A is 1 byte, this integer is 4 byte, and again the character is 1 byte, that means total 6 bytes. So user is expected to have 6 bytes for the example 1, but that is not the case with the structure, because the structure will do the padding. That means it adds extra bytes to make it all the elements more aligned, because this CPU we are discussing is a 4 byte CPU. All the elements we are storing in the structure should have aligned for the 4 bytes. Say for example, the compiler adds padding bytes so that we can have multiples of 4. Say for example, because the character A, the first character is 1 byte, so it stores the character A will have 1 byte, but it will add 3 bytes as a padding, so that the next element B will be aligned to 4 byte memory. Thus next byte will be next variable can be stored and aligned to the 4 byte, and for the character C, no, again the 1 byte and next 3 byte will be added just to make it the whole size multiple of 4. That means this 4 bytes, 1 plus 3 bytes padding, 4 bytes, 1 plus 3 bytes padding, then 4 bytes for the integer and 1 bytes for the character and 3 bytes for the padding. That means total 12 bytes will be used for this structure instead of 6 bytes. So there is one catch here. We can reduce the padding here, extra padding, unnecessary padding we can avoid like this. So we try to group all the larger variables, larger data types in the first, then sort all the same number of same type of data types in the lower order. So in this way, so you can see the int is mentioned first, then the character, they grouped, So in this way, the first integer will have 4 bytes, then two characters will be have one byte, and 2 bytes will be added uh, as a structure padding. That means total 8 bytes will be used for the same number of data type, same number of members. Here in the first example, it was taking 12 bytes, but here in this case it takes only 8 bytes, 4 bytes for the integer and 2 bytes for the character plus 2 bytes for the padding. So in this way, the size of the structure can be reduced with a proper grouping of variables. Okay, this is with a real-time example. This is the normal structure padding. You can see the size of structure. So size of structure is printed for example 1 and size of structure is printed for example 2. So size of structure example 1 is 12 bytes, 8 bytes. The only change is the arrangement, sorting of the data types.